All right. We will start on module 3. Some people struggle with the electrical stuff, especially whenever we're doing resistors in series and parallel. But I promise you, I'll work problems till I'm blue in the face, and we'll get y'all through the electrical side of stuff. But you have to have some type of electrical background if you're doing instrumentation. Like you have to, like the concepts have to somewhat make sense. My first highlight on page 1, the capacitance. The first sentence of capacitance is an online test question. Capacitance is the ability of a capacitor to store an electrical charge. In so many ways, like a capacitor kind of acts like a battery, but just in so many ways. So first sentence of capacitor is highlighted. The third paragraph on page 1, the first sentence is highlighted. In a purely resistive circuit, the relationships between voltage, current, and resistance can be calculated by applying Ohm's law. You don't know what Ohm's law is?
Law of resistance.
Law of what?
Resistance.
Voltage.
I don't exactly know the law.
E equals I times R. What does E stand for?
Energy.
Voltage. Voltage, it stands for voltage because another name for voltage is electromotive force. There's plug-in right there.
Oh, no.
Oh, it's right there. Just leave it.
That's awful.
Oh, yeah.
You sure?
Electromotive force. You don't know what I stands for?
Current.
Current, and R is resistance. So that's some of the biggest stuff to realize is E stands for voltage, and it's represented by volts. Like that one seems pretty dumb, or not dumb, but pretty basic. I stands for current. Current's measured in what?
Amps.
Amps. So you kind of have to get the idea of like what the symbol is, what it's measuring, and then what it's measured in. R is resistance, and it's measured in
Ohms.
ohms. O-H-S. Symbol for amps is A. Symbol for voltage is E. Symbol for ohms is the Greek letter omega. So, and they say it's in a purely resistive circuit. So most circuits that you guys are going to come into contact with are not going to be purely resistive. Anytime you add an inductive load to stuff, an inductive load would be like a motor. Any type of motor is like an induction motor. Like that's going to be a little bit different, so you're going to have to do a little bit different equation. But this is the most basic electrical equation, and you're going to need to know how to like move stuff around. So if you have, if you're given 2 of them, you can always find the third one. So if I was given voltage and resistance, I wanted to find I just need to know that I is going to equal E over R. Is everybody good with moving stuff around on either side of that equation? 1-1-1 resistances in series. Third sentence. In a series, good or no? Okay. Yeah. 1-1-1 third sentence is highlighted. In a series circuit, as shown in figure 1, the current I is the same at all parts of the circuit. So if you're looking at this circuit on the board, a lot of people don't, like whenever electricity was kind of first formed, they thought that ions flowed from positive to negative, but later on they found out that they flow from negative to positive. So ironically, if we would have figured out more about electricity, like this would actually be reversed. But current flows from negative to positive. There's a negative buildup of ions in the negative terminal of a battery, and then they flow towards the positive. But my current at every single resistor, and these just represent loads. So this represents a resistor, resistor, but they just represent some type of load, whether that be a light bulb or I don't know, anything that you're turning on. These can represent a load. The next sentence is an online test question. This means that the current flowing through R1 is the same as current flowing through R2 and R3. It is also the same as the current supplied by the battery. So my current is the same in a series circuit. Current is the same at every load. Good. Page 2. When I am adding resistances in a series circuit, I just add up what the resistances are, and that's the resistance total. So if I had, and these are both series circuits, so it's one thing after the next, right? So if I was finding my resistance total for these three resistors, what would my resistance total be? 225. Does everybody go with that? Resistors in series, you just add them up. So I have the highlight on page 2, resistance total, or RT, equals R1 plus R2 plus R3. So if you have resistors in series, you just add them up. What's my resistance total for the second one?
Okay, 120.
120. Go with that. All right. The harder part, 112. Finding total parallel resistances. So this is harder, but more important, because it's like your house. Your house is wired in parallel. Your all your hots are connected together, and all your neutrals are connected together, right? So those, it's a little bit different trying to find the resistance total of in parallel for an equation. So I have the equation resistance in parallel, resistance total equals 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. You should have that. You're going to have several questions that use that formula, right? So if I had, I might as well use that over there. Well, I can do it for this one. So they have 3 resistors right there. R1 is 2 ohms, R2 is 4 ohms, and R3 is 8 ohms. I will tell you, whenever you are doing these problems, the neater and more precise you can be on your scratch paper, the easier it's going to be. People struggle with fractions, especially whenever there's fractions inside of a fraction. I'm not a very neat person, but I take as much paper as you need to do these problems, and it will help you not get lost. Do not skip steps, even if stuff seems easy. That's where I see people mess this stuff up. So my equation is, come on. Resistance total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. R1's 2, R2's 4, R3's 8. So I come down here at 1 over 2 plus 1 over 4 plus 1 over 8. This is the hardest part where people get mixed up, is trying to remember how to find least common denominator or trying to put this in their calculator. If you're good, like I would recommend getting, it's hard to put this in a phone calculator. I like these little cheap, they can get these for about $10 at Walmart. I like these. It's pretty easy to deal with. Your phone calculator, I don't think is. So I'm gonna find least common denominator. What's the least common denominator for 2, 4, and 8? 8. Everything can go into 8, right? So I'll just write it back out with the denominators of 8. 1 over 2 goes into 8 how many times?
3, 4.
4. 4 eighths plus 4 goes in 8 how many times? 2 eighths. 8 goes in 8 one time. So now I can add them up, right? Now I have 1 over 4 plus 2 plus 1 is 7 eighths. So you can either put that in your calculator, or there is a reciprocal law that you can use in order to get the answer for this. So a law of reciprocity, the reciprocal law just states that if you have a fraction on the denominator of a fraction, you can flip it and get rid of the 1 over. So all you do is you can take this and flip it over the numerator, and that gives me 8 over 7. I don't know what that, like that's 1.1 1/7, whatever that is in your calculator is going to be your answer. Does that make sense?
So that's our system. Because we're looking at the system in RT.
Yeah. So I think they're going to do the. They didn't do it. But your answer to that one was 37. Did they not do? Oh, it is. It's done. So you can also do it by decimals. Like they did it in the book with decimals. So they did 0.5 plus 0.25 plus 0.125. So you can also do it that way. Just do not, if you're doing it one way, do it that way. Like I've seen too many people mess up where they're like trying to mix stuff together and they'll get lost and stuff. But keep stuff the same. Another thing that I see people do that you have to watch for, like if you are putting this stuff in these things in decimals, like I know I got all of that. If you're putting these in decimals, something I see people do is do 1 over, what's a half in decimal?
0.5.
0.5. I'll see them go 1 over 0.5. You just did the equation, like 1/2 is 0.5, so it's not 1 over 0.5, it's just 0.5. That makes sense? Like just don't make that mistake. The fractions get people too bad. There are other equations that allow you to make this a little bit easier. I will say before we go into those, this works every time. No matter how many. If I had 6 resistors, I would just keep on going. 1 over R4, and then so on and so on. That works every single time, whether you have 2 resistors or 1,000 resistors. That one works every time. If you have just 2 resistors, you are allowed to use that equation that's in the top right of page 3. The R resistance total equals R1 times R2 plus over R1 plus R2. So we'll just go to so if I had 2 resistors in parallel, if I had a circuit, that is not the circuit. So, series or parallel?
Parallel.
Parallel. Parallel is if the starting points and the ending points both are connected together, they are parallel. So if I wanted to find the resistance total of this, another equation I can use is R1 times R2 over R1 plus R2. So label these R1, R2. So R1, 5 times 10 over 5 plus 10. So that gives me 50 over 15, whatever that math is. 3 point something. Huh?
3.5.
Can't be 3.5. It's like 3.25 or something like that. 3.33 maybe. What is it?
3.33.
3.33 repeating. So that's one way of doing it. But again, you can also, resistance total is equal to 1 over R1 plus 1 over R2, 1 over 5 plus 1 over 10, 1 over, what's common denominator for 5 and 10?
10.
10. How many times is 5 going to 10?
2.
2 tenths plus 1 tenth. And that gives me 1 over 3 over 10. Reciprocal law allows me to take 10 over 3, which gives me 10 over 3, which is the same thing as 3.33 repeating. Does that make sense? Either way, you can do this one. One more way that you are able to reduce down parallel equations is if you have the same, this only works if you have the same resistances for a number of resistors. You are able, that equation on the right or the left-hand side of page 3 that says RT equals R over N, you can take, this is the hardest one for people to get, but you can take those resistors. So I have two 200 ohm resistors and divide by the number of resistors that you have. So if I have two 200 ohm resistors and divide by 2, 200 divided by 2 is what? What? 100. 200 divided by 2 is 100. So they're saying both of these together is equivalent to 100. So now I have these are breaking down. I have a 100 ohm resistor, a 100 ohm resistor, and a 50 ohm resistor. Does that make sense? If I have 200 ohm resistors, what's that equivalent to? 50. So if I have 200 ohm resistors, I divide 100 by the number of resistors I have, which is 2. 100 divided by 2 is 50. And then I have two 50 ohm resistors. 50 divided by 2 is 25. So you see how they broke this? And they started with this and ended up with the equivalent resistance over there. Does that make sense to everybody? I don't recommend that one until you are extremely comfortable with doing the other ones, because that one will mess you up. Let's work a couple of these. Everybody read that? Take a minute, see if you can figure that stuff out. Anybody want some scratch paper? I want scratch paper. Right there. Let me know if those won't take super long, but let me know if they'll get stuck somewhere. Yeah. This one. Yep. Where's the first one? First one.
So, right.
You don't have to write it down.
As long as you can. Just that all together.
Whenever y'all get it, I want to see what y'all got. That's all it's got.
I just finished the first one.
Let me know if y'all can't read my handwriting. It's not the best. Y'all stuck somewhere, let me know. Josh, you got him?
Oh, yeah.
Sure.
Tried it. That's fun. All right. I'll look here. That's fun.
So, I think you just did, this is the map. Add these back up.
That's right. So this, yeah, 38. Top one was correct. 37.
That's close. Yeah. A little far off. So your equation, you start with the, so that's not the equation you want. You want this, you want to highlight this equation.
Right. So yeah, just all, cross all that off. You might work through this one first.
Yeah, I'm trying to.
I'll work through these. And we're gonna keep going, because I can't spend too much time on them. So, first one, is this series or parallel?
That's your,
Series. What's my equation for resistors in series?
R1 plus R2.
So you just add them up, R1 plus R2 plus R3. So 10 plus 75 plus 12 is 97 ohms.
oh, no,
Everybody?
the first one, yeah.
Yeah, first one's good.
Oh.
Everybody go with that one? So next one. Can I do this? There we go. All right. What's my equation for 4 resistors in parallel?
1
Just so 1 over.
1 over R1.
Good? All right, plugging them in. 1 over 5 plus 1 over 10 plus 1 over 20 plus 1 over 40. 40. All right, I'm gonna do this one both ways. So I'm gonna do common denominator first. So 1 over. What's the common denominator for 5, 10, 20, and 40?
40.
40. So 5 goes into 40 how many times?
8.
8 over 40. 10 goes into 40 how many times?
4.
4 40ths. 20 goes in 2 40ths plus 1 40th. 8 plus 4 plus 2 plus 1. 15 40ths. Law of reciprocal law allows you to flip this over. So that gives you 40 over 15. If you put that in your calculator, it's going to give you 2.66 repeating. 66 repeating ohms. Make sure y'all are putting the terms on there whenever you're doing that. So if I was going to do it by decimals, I can come out here and do decimals. So instead of, this is separate. So instead of over here, 1 over 5 is what in decimal? 0.2. 1 over 10. 0.1. 1 over 20. 0.05. And 1 over 40.
0.025.
0.025?
Yeah.
0.25. All right. Add those up, and I get 1 over 0. What'd y'all get? 3 something? 2, 3. 3. What is that? 0.3. 5 plus
0.375.
375. Good. If you put that in your calculator, you're going to get 2.66 repeating ohms. Everybody follow that? And again, just like I said, I'm recording all these, so if you need to go back and watch this or watch me go through one, go back. Like I'm gonna try to post this either tonight or tomorrow morning. So it'll be on there for the weekend. All right, moving along. Page 4. They make it even more fun. Series parallel circuits. So they add them together, which is what most of your circuitry and stuff is going to be. My highlight in 113 is on the right-hand side of the page. That middle paragraph on the right-hand side of page 4 first two sentences. After determining that a circuit is series parallel, redraw the circuit so that the branches and series loads are more easily recognized. This is especially helpful when computing the total resistance of the circuit. I'm going to give you the highlight, on page 5, right above those first set of steps, highlight that paragraph. You're going to want to know how to break down these series parallel loads or circuits. So first paragraph on page 5, to find the total resistance, reduce the circuit to its simplest form. Usually this means simplifying the values of all the resistors into a single or equivalent value. This simple series circuit has the equivalent effective resistance of the series parallel circuit from which it was derived, and also has the same total current. There are 4 basic steps in reducing a series parallel circuit. So they give you this circuit right here. That looks pretty confusing, right? But if you're just walking through, you can see that whenever you're comparing R1 to R2, is R1 and R2 in series or parallel?
Series.
They're in series. Is R2 in series or parallel with R3? Parallel. Is no. Series, because this is just, if I took off, if I just deleted R4 and R5, right? And just had these are in series, right? So same thing, if I deleted R2, R1, R4, and R5, and R3 would all be in series. But R2 and R5, R2 is in parallel with R4 and R5 because they start at the same point and they end at the same point. So in order to simplify this, they want you to break it down and redraw it. So now I know that R1 is in series with R2, R4, and R5. R1 is in series with the 3 of those, and they are R4 and R5 are in parallel with R2. 4 and 5 are parallel to R2, start and stop at the same point, and then the rest is in series with R3. So what they're going to do, if we wanted to work this as a problem, we can say, let's just put some values to it. Just 1 ohm, 2 ohms. No, let's not do that. Do something easier. 5 ohms, 10 ohms, 5 ohms, 10 ohms, and 10 ohms. All right. So same thing, we move that over here. 5 ohms, 10 and 10 was 2. 10 ohms. And R3 is 5 ohms. So the first thing that I'm going to do is I'm going to break down just this circuit right here, right? Because I want to break down this circuit and put it into an equivalent circuit where I can pretend like there is an equivalent resistor right there, right? So our R4 and R5 in series are parallel with each other. Series. So what do you do with series load or series resistances? Add them up. So I can say, I can get rid of all this and say it is total of 20 ohms. 20 ohms. Good. So now I have a 20 ohm resistor in parallel with a 10 ohm resistor. Right? So now I can go do the math and say I have a, what did I just say? 20 and 10 ohm. So my equation that always works is resistance total is equal to 1 over R1 plus R2. I do the math, 1 over 20 plus 1 over 10, common denominator, 1 over 20 plus 2 over 10, which gives me 1 over not 2 over 10. 2 over 20. 20 gives me 1 over 3 over 20. And then that calculates to be 20 over 3. Will somebody put that in their calculator? 18. That's not good. Is that what that is?
Yeah.
6.66 repeating. So that is my equivalent resistance. If I go with that, going back to this, now I can get rid of all of this and pretend that I just have one resistor right here that is 6.66 repeating ohms, right? So if I get rid of all that, this resistor, and this resistor are in what?
Sir.
And what do you do with series resistances? Add them up. So 5 plus 5 is 10 plus 6 is 16.66. My resistance total would be 16.66 repeating ohms. Getting there? I know it's this isn't easy for. I did not do well with this in college. Like I made a C on this test. I didn't do well with the series parallel loads. So you might want to read through those steps and how to break down the circuit. Page 6 and 7. Move on to 121. Ohm's law with series circuits. We're going to talk about applying Ohm's law to series circuits. So, in a series circuit, amperage is what across every load?
Same.
The same. In a series circuit, voltage is different across every load. You have a voltage drop across each resistor. So that is something that you have to get inside your brain. In a series circuit, current is same at all loads. In a parallel circuit, current is, I don't want to say current is different, because if you have the same size load, it's going to be the same. But current is based on load resistance, or based on load, right? The other side of that is in a series circuit, voltage is based on loads. In a parallel circuit, what would you guess voltage is?
Consistent.
Is the same. Your house is wired in what? Parallel or series? Parallel, because the voltage at each one of your plugs is what?
It's all gonna be 120.
It's all going to be 120, right? So you have the same voltage to every plug. But if I plug in a toaster and run a toaster, and I plug in a cell phone charger, are the amperages going to be the same? No. Cell phone charger takes very little amperage. Any kind of heating device takes a lot of amperage. So the amperage is in a parallel circuit is based on the type of load. That makes sense? Voltage is the same. So they're going to want you to find voltage drops. Not let me write on that marker. they're gonna want you to find voltage drops across each of these. So we're gonna get, I think they talk about Kirchhoff's laws and stuff like that, but all your voltage drops have to add up to your voltage total. So you'll have voltage drop across each of the 3 of these. And if you add them all up, they'll be 95 volts. So if I'm finding my voltage drop across R3, the first thing I have to do is find my current total, because my current's going to be the same at every one, right? So I need to find current total. What is my equation for current?
That's E divided by R.
E divided by R. But if I'm saying current total, it's my voltage total divided by my resistance total, right? How can I find my resistance total?
Add them all up.
Resistance total is equal to R1 plus R2 plus R3, which is 20 plus 50 plus 120. 50 plus 120, 90, 190.
Might be 124, 12.
Is everybody good with that?
Yeah.
So our resistance total is 190. So I can work this equation now. What's my voltage total?
95.
95. What's 95 divided by 190? That's half, isn't it? 0.5. Half. Yeah. So 0.55 amps. So that is my current total. So I have the same, I have 0.5 amps here, 0.5 amps here, and 0.5 amps here, because my amperage is the same at every load, right? So now I can go find my voltage drops. What's my equation for voltage?
E equals I times R.
So if I'm wanting to find my voltage we'll start with 1. My voltage at 1 is equal to I, which your I at 1, I at 2, and I at 3 are all going to be the same, and it's going to be your I total. So it'll be E1 equals I total times, what resistance do you think I'm using? 20, R1. So 0.5 times 20 is what? 10. What is that represented with? Volts. So I have 10 volts right here. Everybody go with that? Come over here. E2.
25.
E2 equals I total times R2, which is going to be 50 times 0.5. 25. Nah, I'm not good. 25 volts. So good? This is what I don't want y'all to do, is get messy like I do. E3 is equal to I total times R3, 0.5 times 120 is 60 volts. And then see what I said about what's 60 plus 25 plus 10? 95. 60 plus 25 plus 10 is equal to 95 volts. So I drop all of my voltage across the series circuit. And I end up with my voltage total. Getting there? I know it's a lot. So they, on page 7, highlight that first full paragraph Now find the voltage across each individual resistor. In the series circuit, the current stays the same throughout each resistor. That is I equals 0.5 for each resistor, and then highlight E1, E2, and E3. And that's what I went through and just found. So you just need to know, how to do that.
Was there any highlights on 6?
There are no highlights on page 6. You need to know Ohm's law, E equals IR. Applying Ohm's law to parallel circuits. 1, 2, 2, I have the first 2 sentences highlighted. A parallel circuit is a circuit in which 2 or more components branch off the same voltage source. These branches are like their own individual series circuits, but they are all connected to the same voltage source. Right above example 1 on the right-hand side, I have that little short 1-sentence paragraph highlighted. With the same applied voltage, any branch that has less resistance allows more current through it than a branch with higher resistance. That kind of, like if you just think about that, that makes sense. If you have less resistance, it's going to allow more voltage. If you have more resistance, it's going to allow less voltage. With the same applied voltage, any branch that has less resistance allows more current through it than a branch with higher resistance. On page 8. So same thing, but different with parallel circuits. I could have a voltage here, and my voltage is going to be what for every resistance?
The same.
It's going to be the same because they're all connected to the same point, right? All connected to the same point on one side and all connected to the same point on the other side. What's going to be different?
Your
The voltage.
actually different.
My amps will be different. My amps at every one will be different based on the load. So just like in a series circuit where all the voltage is added up, it's the same thing for a parallel circuit with current. So I total is equal to I1 plus I2 plus I3. So you'll dissipate all your current as you go. So I don't know that they give you, on page 8, have that highlight, like I have I total is equal to I1 plus I2.
That's on 7, I think.
It is on both, it's on both pages. But yeah, either one, I just want you to know that current in the parallel circuit, as you add, like you just add all the current up and you get your current total. I'm going to give you some more highlights, and then we're just going to work on these towards the end. Because I feel like I said, I'm going to work on these for a while, but I want to give you all of the highlights. Page 8, I just highlighted the heading of 1, 2, 3, applying Ohm's law in a series parallel circuit. Like you're just going to need to know.
Where's that? Which page? 8?
Page 8, 1, 2, 3, just highlight the heading.
Like the 1T, 1, 2?
1.2.3, applying Ohm's law in series parallel circuits. Just the heading of that.
Oh,
You're going to need to know how to do that. So like all those steps and stuff are going to be beneficial. And then flip over to pages 10 and 11. Like I said, I'm gonna give you all these highlights, and then we're gonna do some problems. Kirchhoff's current law on page 10, 131. Come on. I have, as an online test question, I have, IA plus IB minus IC equals 0. And just the definition of that in 131, I'm just going to read through it. In its most general form, Kirchhoff's current law, which is also called Kirchhoff's first law, states that at any point in the circuit, the total current entering that point must equal the total current leaving that point. For parallel circuits, this implies that the same current in a parallel circuit is equal to the sum of the currents in each branch. Kirchhoff's voltage law, 132. You need to know the first sentence of 132 is highlighted in the bottom left of page 11. Kirchhoff's voltage law states that the algebraic sum of voltages around any closed path is 0. So that's the same thing, like your voltage drops in that first one, they add up to 95, but they just want you to know that you take 95 and you minus 20, minus 25, minus whatever the other one was, and we're going to add up to 0.
What's the highlighted there?
132, first sentence. Kirchhoff's voltage law states that the algebraic sum of voltages around any closed path is 0. So that's on page 11. Right above that note, above that green note on page 11. And then the equation for that is in the top right of the page. EA, I don't like that they changed their terminology up, but voltage total, they'll write voltage total as ET sometimes, as voltage total, and then they'll also write it as EA, which just means applied voltage. It's the same thing. However you want to do that whenever you're doing these equations, just keep it the same. Don't confuse yourself with changing it back and forth. So that EA equals E1 plus E2 plus E3 is highlighted. Loop equations 133. Second sentence is highlighted in 133 on page 11. Any closed circuit path is called a loop. Any closed circuit path is called a loop. So, page 13, take a few minutes and see if y'all can knock out that section review on page 13. I'm also going to give you a couple problems on the board to see if you can work out. Let me know if y'all have issues, and I'll help you work through them. Work the ones in the book first. You know if you have problems, then see if you can work that one on the board. Let me know if I get stuck.
You want the exercise from the page 10, 11, and,
What's that?
so you say this exercise and also from the book, right?
Page 13.
Okay.
Section review on page 13, and then one on the board.
Oh.
Work out the ones in the book first. I need help.
Yeah, I'm still on one. I don't even know what the equipment resistance is.
Resistance total.
Oh,
So all they're doing is asking for resistance total. So what's your equation for resistance total?
depends what they-
For
they said. So it's this one.
correct. So go ahead and write down. Start on a new sheet of paper. Write down your resistance total equation for 3 resistors. One over
Yeah, I know that it is.
1 over R1 plus 1 over R2 plus 1 over R3.
Comes down, it would be 200.
There you get all of them.
Thanks.
Two and three are not correct. What'd you get for the one on the board?
Which one? I didn't get that.
See if you can figure that one out.
That's, I got another one. You got 2. Maybe I gotta do fractions. I don't really like fractions.
So what's 1 divided by point, or what's 1 over 40? Put that back in your calculator.
There you go.
0.025. So put that, like if it comes out like that, don't do any rounding. You just put in 0.025. If you put 0.3, if you round it, it'd be 0.03. But if you use the exact one like that, put it all in there. Oh, you put 0.2, not 0.02. 0.05.
In there?
Not sure. So you got these.
You wrote those down, that's that, right? So now you write that in parallel with that. Because they start at the same, they both start at the same point, and they both end at the same point. So you have a 40 in parallel with a 40. That makes sense?
This is serious, right?
Well, the whole thing is series parallel.
Yeah. But like,
These two are in parallel with that one, but these are in series with each other. So what can you do if they're in series?
this one, no.
No, you're gonna have to go further back. But if resistances are in series, how do you find the total?
Like adding,
Yes, you just add them.
yeah, so, but first I have to, well,
Yeah, don't do that. Don't mess with this one first. What you wanna do is break this down into one resistor total. So you can draw the circuit again and then just add these together. So come down here and draw this again, but instead of two resistors here, draw one. And what's 20 plus 20?
yeah, 40. So we, 40, so this one will be, this is parallel. No,
This is series.
this is serious, so. These two. And, so then I had to add this.
Nope. So then now you have a 40 ohm resistor in parallel with a 40 ohm resistor. You have to figure out what the equivalent resistance is for those. Okay. Yes. You trying to figure out what the equivalent is?
Yeah, with this one, like maybe to make like this.
So if you have two 40 ohm resistors in parallel, what's your equation for parallel resistance?
It's not divided by the, no, what's, I was trying to do like a 0.001 or point.
Now, find your equation for parallel circuits. So write that down. But you only have two resistors, so
Yeah.
only go out to R2.
No, then 40, so.
No. See, you have 1 over 40 plus 40, but it is 1 over 40 plus 1 over 40. Right?
Yeah.
Yes, so that is correct.
Yeah.
So what's 1/40th plus 1/40?
Yeah, it's 80, right.
Nope, you don't add the denominators, you just add the numerators, they have common denominators.
Okay.
So it would be 1 over,
1/40,
no, what's 1 over 40 plus 1 over 40?
1/80. So it'll be-
It's not 80, no, you do not add the denominators together. You just add the top,
Oh, like 2?
2. So you would have 1 over 2 over 40. Over 2 over 40.
40. Okay.
So if I can do the reciprocal equation and flip that upside down and have 40 over 2. That's 40 divided by 2. You
It
don't
will be
need to-
20.
Right. So now you have an equivalent resistance for all of this that is 20. So right now you have this. So right now you turn this into, that's your R1. But then you combine all of this into one resistor, and you have the one down here. So this is your equivalent resistance of 20, and then you have 5 here,
Yes.
and you have 10. So what kind of circuit is that?
Now it's in series.
Correct. How do you find the series?
Like I.
Yep.
all those?
Yep.
R1. It has to be like, or like
Yeah.
that one, the top. Yeah, I just practicing words.
All right. I'm gonna work. Actually, I'm gonna do the book first. All right.
Yeah, 35.
I can do that. A circuit contains 3 resistors in parallel. They are 40, 50, and 200 ohms. What is their equivalent resistance? Equivalent resistance just means resistance total, right? So if I wanted to draw this circuit, I would have 3 resistors in parallel. 1, 2, 3. R1, R2, and R3. And then I can name them or write them 40, 50, and 200 ohms. What's my equation for 3 resistors in parallel?
One over 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3.
So I plug in my knowns. So I have 1 over 40 plus 1 over 50 plus 1 over 200. You can do decimals if you want. You can put them in your calculator and do decimals. I like to do fractions, so I'm going to do fractions. I'm going to keep going on this side. So I've got 1 over, what's my common denominator for 40, 50, and 200?
200.
200, right? 40 goes into 200 how many times?
40. 5.
5 times, right? 5 times 40 is 200. 50 goes into 200 how many times?
4.
4 times. 200 goes into 200 1 time. 5 plus 4 plus 1 is? 10 over 200. I can do the reciprocal all right here, and I can say, I can flip that over and have 200 over 10, which is 20 ohms, which is B. Everybody go with that? Always write it out if you have to, and then take up as much room as you can. Do not skip steps. That's what's going to help you the most. Second one, 2 resistors, R1 and R2, are found in an instrumentation series circuit. R1 is 50 ohms, R2 is 250 ohms. If the current in the circuit is 4 milliamps or 0.004 amps, what is the voltage drop across each resistor? So key in on things. This is a series circuit. So I have 2 resistors in series. There's 1, there's 2. What are my knowns that they give me? R1 is 50 ohms. So we'll designate this R1 is 50 ohms. And R2 is 250 ohms. Right? Do they give us any other information?
The 4 is.
The current in the circuit is 4 milliamps or 0.004 amps. Key in on that. My equation is E equals IR. The I, they have to be in their original form. So you can't use milliamps. You have to use amps. That's why they give you 0.004 amps. So my current total for this is 0.004 amps, right? So I have what's true about a series circuit as far as amperage goes?
It's the same.
It is the same. So I have the same amperage here as the same amperage here. So they're asking what the voltage drop is across each. So if I have 0.004 amps here and 0.004 amps here, what's my equation for voltage? Voltage equals I times R. So if I want the voltage drop across R1, I'm using my I total and R1. So I total is 0.004 times 50. What is that?
3.2.
0.2. You could look over and see that there's only one that has 0.2, but go ahead and do the other one. And I'm just going to say E2 is equal to I total times R2, 0.004 times 250. And you should come up with 1 volt. So 1 volt and 0.2 volts. The answer is D. Everybody good with that? Number 3, a motor has 3 heaters of equal resistance connected in series. So I've got a circuit, 3 resistors in series, equal resistance. The supply voltage is 270. What is the voltage drop across each resistor? So I know that voltage is voltage in a series circuit is going to be based on the load. But since every load is exactly the same, they're going to have the same what?
Voltage drop.
Voltage drop. So if I have 3 loads and I have 270 volts, how do I find the voltage across each load?
Divided by 3.
Divided by 3. 90 volts, which is A. Everybody go with that one? Huh? This is all being recorded, so you can also get on there and pause it and see that. I know I'm going fast, but this is,
Yeah.
we're in section 1. This problem right here. What is my first step to break down the circuit?
Figure out what's in parallel and what's in series.
What's in parallel and what's in series. So I can see that R1 is in series with this combination, right? Which is in series with this. So what do I want to do first?
Resistance in parallel.
I want to break this down. So I want to disregard this and just break this down. So just R2, R3, and R4, how do I first start combining those?
20 plus 20.
20 plus 20, because R2 is in series with R3. Everybody good with that? R2 and R. So if I combine those together, how do you find resistance total of series circuits? Add them up. So I'm doing this the long way. So my new picture would be R1. This would be, I named this R23, R4, and R5. I don't remember. and 45. Come on. Ten ohms,
40 on top,
40,
40 at the bottom.
40, and 5, right? Still breaking this down, this R2, 3, and R4 are what compared to each other? Are in what? Are in parallel. Everybody good with that? So how do I combine parallel resistances?
1 over R1, R2, 3 plus R4.
1 over R1 plus 1 over R, come on. 1 over R2, or resistance total is equal to R1 times R2 over R1 plus R2, or resistance total is equal to the resistance over the number of resistors, because what? They're the same. So I can do this. I can do the first one. It worked. The first one works every time. Everybody has to know how to do the first one. So resistance total is equal to 1 over 20 plus 1 over 20 equal to 1 over 2 over 20 is equal to 20 over 2.
Should be 40.
Yeah, 40. Why did I say 40?
Yeah.
Where did I mess up?
Just
You
do it
put, you
then.
put 1 over 20, it's supposed to be 1 over 40, right?
1 over 40.
Yes.
That's it.
R2, 3 is 40, not
My
20.
bad. My bad. Sorry. 40, 40, 2 over 40, then 40 divided by 2, which gives you 20, right? Or the next one, resistance total is equal to R1, which is 40 times 40 over 40 plus 40. What's 40 times 40? 1600
Divided by 80.
divided by 80 will still give you 20. My resistance is what?
40,
How many resistors do I have?
20.
Which gives me 20. Everybody understand how you can get there 3 different ways? So now, I have this equation, R1 is 10 ohms. R5 was 5 ohms. Not that. 5 ohms. And this is R, we're just going to say 2 through 4. What was the equivalent of that? 20 ohms. What kind of circuit is this?
Series.
What's my equation for series circuits?
Same thing, right?
R1 plus R2 plus R3.
Plus 10 plus 20 plus 5. 35.
Good? All right. I think this is going to take us a while to go through. So I'm going to give you some problems to do for homework. Okay? If you need to, you can write them down if you want to, or you can pull the video up and get them. But,
You have pictures.
huh?
Okay.
You have like pictures of just problems.
Put your.
I'm just going to make up problems on the board.
What I'm thinking is like. Okay.
All right, you got 3 problems. I want you to find the resistance total of number 1. I want you to find the current total of number 2. I want you to find the voltage drop across each resistor in number 3.
Wait, the first one is to find the resistance.
Yeah, I got them.
Find resistance.
Find resistance total. If you have that, you're good to go unless you need to take the test from module 2. Like Alex and Eric. You gotta take that.
That 10 in the middle of the two? That's 10.
Yeah,
ohms?
sorry. Yep, 5, 10, and 20.
And then is find the resistance, the total.
Current total, I total is number 2. I'm gonna stop the recording. But I'm gonna post it. I'm gonna post it here shortly. So if you need to go back and watch any of these problems and stuff, you can come back to them.